Well, hello everyone, and welcome to Saylor Academy's PRDV 401 Introduction to JavaScript. This is our Unit 4 review. If you haven't seen any videos in this series yet, check down in the description below. They're linked there, as well as a link to the entire course, because these videos are a supplement to the entire course. So make sure you guys are following along with the course with us. And if you have any questions as we're going along, you can leave them in the chat box on the side. I'll be keeping an eye on that. Or you can leave them in the comment section below for if you're watching one of these later. But, everyone's busy, so we'll just hop right into it, and I'll hand it over to Susan Hoyt, and she can get us going, and I'll be here if you guys need me.
All right, thanks, Mike. All right, so we're in Unit 4 now, so let's get started. Click my thing. Okay, who am I? I am Susan Hoyt. I'm from Houston, Texas. I have been a computer science educator for about 25 years. I've been with Saylor for a little over a year now. I do love to teach coding. It opens up a whole new world for so many people, and there's so many instances that you might need it or use it or find a job that uses it. In my spare time, I do hang out with my dogs. I apologize if somehow you hear them in the background barking. And I do like to read a good book, and I'm all about the sand and the beach and the warm weather. All right, so this is going to be our first in the series of 3 courses that will eventually be out that cover the JavaScript language. There's 6 units in this course. We are on Unit 4 today. So we have done 1, 2, and 3, and those are already on YouTube, and you can go look at them. If you missed those, you can always go back and look at those and get caught up on that sense. Whoa, sorry, I do that all the time with this mouse. All right, so we're going to start Unit 4. Last week we did cover Unit 3. In that, as we talk about the certification, I always want to say it every time that we go through this. On the course final exam, not the each unit test, but on the course final exam, you do have to score 70 in order to receive your certificate. You can retake that exam as many times as you need to get that actual 70, but you do have to wait a week apart to take the other test. But you can continue to do it. All of these unit tests and all of these assessments at the end of the units will help prepare you for that. So that way you may not have to take it more than one time. Okay, we'll also talk about Code Runner, and we'll talk about Code Runner again today, just so that you can kind of see how that works for coding in our assessments. And then we actually used some developer tools last week to run some of our code examples. And these are the topics that we covered. We did a lot of topics last week, so it's a pretty long video. So we had variables, operators, keywords. We did values and data types. We talked about operators. We actually wrote some simple JavaScript statements. And then we looked at a few different editors. We will look at JS Hint again today. We will look at Replit again today. And we will look at Code Runner again today. So you will see all of those again today. Whoops. All right. So completing this unit should take you approximately 2 hours. What are we going to cover in this unit? We're going to cover conditional statements. So we're going to talk about if else, while, switch. I actually didn't put the rest of them on here, but we're actually going to talk about do while, and we're going to talk about for loops and test all those out and do some examples and see what kind of little small mistakes that you want to be careful of. We will use relational and Boolean operators with conditional statements. And we'll write some code that implements interactive choices based on a condition. So if you enter something, you'll have a choice based on that. So we'll do some of those examples together. All right, so let's get started on conditional statements. So what is actually control flow? Control flow in your program can be sequential, it can be selection, and it can be repetition. For sequential, we're talking about just a straight line. I start at the top of that program and I just go line by line all the way to the end. And very rarely do I have programs that are interactive that would be something like that. So we definitely have to get past that sequential execution and get into some conditional stuff here. So in our conditional, you see that we're no longer going just a straight line from left to right. We're coming from the left. Okay, now we're going to hit something here. And this is going to be a decision. In this decision, if we select, say, true, we'll go this way. And if we select false, we go that way. So this is a example of like an if statement. So the if statement would have this. If it's true, do this, otherwise do that. And so as we go through, we have some if else's that we'll see. And those if else's will have some more branching off stuff. So we're going to look at some examples and go ahead and start out with our examples here. So in my examples, let me grab over here and I will put them here. I'm going to go straight to the course and show you where this is. So if you notice here, I grabbed the link, but I'm in unit 4. If you haven't done 3, 2, or 1, you definitely want to go back and do those. So I'm in unit 4 and I went here and I'm looking at the control flow. And you see over here, it gives me a table of contents and shows me where I'm at. So right now we're in control flow and conditional execution. So what we want to look at here is we've got some ifs, and here's the little graphic I just showed you. So we're going to grab this if statement and I'm going to bring it into Replit. Remember, I showed you Replit before. If not, it's replit.com. And then you make your own login. And then when I go create, the one that I like to choose is the node.js. Again, if you've seen this, it makes weird names. I don't really care. Those weird names can stay there. And I wait for it to get ready. And then I'm just going to throw my code over here. And I'm going to try it out. So if you see here, I'm going to go ahead and just run it real fast. And I'm going to let you see what it looks like. And then we're going to talk about the parts. So if I run it, it tells me to pick a number. Okay, I have no idea what a number is going to do. So I'm going to do 25. Okay, so it tells me that 25 is the square root of 625. And it only runs it one time because we haven't done repetition yet. So if you notice here, we did our let the number equal. So this is our prompt, which you'll have to use a prompt later in the actual exam for this unit. So remembering how to do a prompt would be helpful. So you can always go back and look at these examples to help you. Now here we're using a Boolean not, which we covered last week. So we said if our number is NaN, we covered NaN last week. So what does that mean? If my number is not a number, then I will do something. And so let's happens if I run it and I say it is not a number. I'm going to say the word 5. Did it do anything? Nope, it did not, because it only will do this if it is not a number. I know that sounds like a double negative, but this is going to return true if whatever I enter here is not a number, it will be true. So if it is not a number, I don't want it to do this. So I want it to be false and not do the if. Because how does the if work? Well, we got the word if, which you can tell is a keyword, just like let is. Then we have the parentheses. These outer parentheses will contain where our Boolean statement is. Whatever statement we put into the if here has to be either true or false whenever it evaluates. So this is our Boolean statement. And then once it evaluates, if this statement is in fact true, then it will come in here and it will do whatever is in here. If this statement is false, in this case, I don't have an else or anything. So that means if I had some kind of statements down here or anything like that, statements. If I had any statements down here, then it would just skip it and go to whatever statement I have down here. Now, if I do something that is a number, so let's do 12 this time. 12 is a number, so it came in here and it did console.log and it said the words, your number is the square root of, this plus means, hey, I want you to concatenate this to this string. And notice whenever it prints out, it's all on one line like that. And then I took the number, which was what they entered, and I multiplied it by itself. Also notice here, I did make sure their prompt was a number. So I need it to be a number in order to do some kind of calculation with it. All right, so now let's move on to the other one. Let's try this one. Now this one is pretty basic. Notice we have an if again, and we have our parentheses. Inside those parentheses has to be some kind of a statement that would evaluate to either true or false. 1 + 1 = 2. That is a statement that could evaluate as either true or false. So let's run it and see what it says. It says it's true. Now, last week we also talked about you can use 3 equal signs so that it makes sure things are the same on both sides. And it's still true that way. So don't forget about these 3 because those are also good things to use. Now, how does this if look different? Because we put it all on one line. Putting it all on one line, that looks fine, but sometimes it's much better to come over here, and Replit automatically indented that for me. But if you indent it over here, then sometimes it's easier to see the actual flow of the program rather than having it all on one line. Because a lot of stuff in JavaScript, you can put all on one line and it looks terrible, but it will still run with no problem. All right, so let's do another one now. And we're going to add in else. So how does the else look as opposed to just an if? All right, we still have our prompt, which is a number. We still have the same if that we talked about, but notice here that now I have an else. The else is evaluated only if the if is false. So if this statement right here is a false statement, then it will execute the else. So when I execute the else, it says, hey, why didn't you give me a number? Because this will only evaluate if it is not a number. Now, some people will, when they first start doing this, they will want to put something here and they'll want to put like else number is, and they'll want to put the opposite here. You don't want to do that because you don't have to, and it will not work. So this else should not have any kind of condition next to it. This else works because if this is false, I do the else. If this is true, I do the if. And that's the only thing that's different on this. So let's do this, and let's do it with 5 like that. And so 5 is not a number. So this became false. So it went down here and said, hey, why didn't you give me a number? Now, if I run it and I actually do the number 5, it actually tells me I went inside the if now and I did this statement. So that's an if else. Now, do we have other stuff that we can use? Notice this one. This one has even more else's. Now, you know how I tried to put this here and I said, don't do that because you really don't want to put a condition there. If you think you might need another condition, then you may need something like this, where you're going if something else, if something else, else if this other thing. So this is a nested if else. So notice for every if or for every else, you've got to match it with an if. You can't just have it randomly there. So if I have this else, I can follow this curly brace back to see what if it connects to. If I don't have curly braces for any reason, an else is attached to the closest if. So let's see what would happen here. We are having them pick a number. If it's less than 10, we should say small. If it's less than 100, we should say medium. And if it's anything else, we're going to say large. So let's try this. All right, so I'm going to do a number less than 10. So I'm going to do 5. Small, okay, that works. If number is less than 100, okay, so I'm going to pick 9. That's still small because it gets hit right here by this one. Now, what do you think is going to happen if I hit 10? 10 is greater than 10. So this one is going to be false. So now it's going to come here, and is number less than 100? Yep. So now it's going to say medium. Now, how do I get this one to happen? Well, it has to be a number that looks like it's going to be, let's try one greater than 100, or let's just try 100 because this one says less than. So let's do a 100. And 100 got us to large. Now, if we had tried to do this with just ifs, we would have run into a problem because let's do this real fast. I'm going to take off these and let's make sure I take them off right. I may have extra curly braces. You with you, don't need you. And I'll put an else here with this. Yes. Okay, so this one matches with that, and this matches with that. So basically, I have an if number is less than 10, do small. If number is less than 100, do medium, else do large. So let's see what happens here and why it looks different. So I'm going to pick 9. So since I did not have that else, it hit this if and it hit this one because 9 is less than 10 and I didn't have the else that made it avoid this one. If I put that else, then it says, okay, I only do any of these else's if this one wasn't true. So when you're trying to do stuff, a lot of times when you're trying to break it into ranges or like say doing grades, anything like that, you definitely need some if else's in there. All right, let's see if I did want to show if you don't put any curly braces after an if. So let me do this. All right, so I could say if number is equal to 10, less than 10, we're going to change this one around a bit. And I'm going to say console.log, whoops, less than 10. Okay, then I'm going to have something else that I want to happen that in the same thing. Console.log, this number is definitely less than 10. Whoops. Okay, so let's say I wanted these two statements to happen if the number was less than 10. So I run it. I'm going to pick a number less than 10. Okay, even though I indented like this, some of you may be coming from Python and you're used to indenting like this and you're like, okay, well, if I indent, it knows I mean it to go with that if. Absolutely not. In JavaScript, you've got to add the curly braces to let it know, hey, I want you to do more than one statement. So now if I do 9, it shows both. Okay, that's if I wanted both. Okay, now what if I only wanted one? I could change it and I can put a curly brace there. Or if I just wanted this to happen all the time, I can leave it like that. So if I wanted this looks great. This looks like this is going to happen all the time. So whoops, did I mess up on? Hold on. What is it? Oh, I've got a curly brace. Hold on. Let's get rid of that one. Try that again. All right, picking a number 9. 9 should be less than 10, and this happens all the time. So again, if I did this, it looks like it's always going to happen. So if I did 10, let's do 10. This happens all the time, even though I indented it, because I did not put it in a curly brace. Or basically, if you want more than one statement in your if, you have to have a curly brace. Let me stop talking in circles. All right, let's move on. Let me see. I think I got all those. All right, let's head on. All right, so we did the first part where we talked about using an if or an if else. So now we really need to talk about loops. So let's look at some while and do while loops. So let's start here. All right, so I'm going to grab this and I'm going to throw it over here into Replit real fast. All right, so if I run this, this will show me all the even numbers between 0 and 12. Okay, so this is great. But what if I wanted all the even numbers between 0 and 5,000? I would not want to write 5,000 lines of code. So that's where loops come in, and that's where they're great to have. So let's look at a loop and talk about the different parts of it really fast. So I want a loop that does the same thing. So a loop has three parts. It has a starting condition. It has some kind of conditional to make it stop. And it has to have a way to change that starting condition so that it gets closer to this condition so that the loop is not an infinite loop. So part one, so this is our part one. Our condition right here is going to be our part two. And our changing of that condition to get it closer is going to be our part three. All right, so let's see what happens when I run this. Exactly the same output. Instead of having all those lines of stuff, I only have these. And the best thing about it is that I could totally make this go to 5,000 if I wanted. Let's just do 500. And easily goes to 500, took a couple seconds, not a big deal. Now, a couple of things to think about, and let's go back to 12. All right, so we went from 0 to 12 whenever we did it. A lot of times you'll see me start counting at 0 because a lot of the computers will count from 0. Now, there's a couple of different things that you can see in a loop. We have the while condition, and just like the if, we have these parentheses, and these will contain a condition that if it's true, it does a loop. If it's false, it would come down here and do whatever statements are down here. So whenever you're doing the loop, things to think about is how you want it to display. If I wanted it to display 0 to 12, like my other one did, great, that's what it did. But sometimes you might accidentally do something like this. And you switch the order of your stuff. And I'm just going to comment out this previous one. So now notice, what am I doing first? I am adding 2 to it before I actually view it or print it. So in this case, instead of it going from 0 to 12, it goes from 2 to 14. So let's see why. When you go through a loop, the first thing it does is it takes your initial value, so the number is 0. So we come here, and is 0 less than or equal to 12? Yes, it is. So immediately I come into the loop. I immediately, in this case, add 2 to my number. So number immediately goes from 0 to 2, and then I print it. So that's where this 2 came from right here. Then what I do, and I'm just going to remove this one for right now so that you don't get confused. Then I don't just go on to the next statements. I come back up. And when I come back up, my number was 2. Okay, that's what I just printed. So now I come back up to my condition and I say, is 2 less than or equal to 12? If 2 is less than or equal to 12, then I do the loop again. So it is, so I would do 2 plus 2, so now number would be 4, and I would print 4. Then I would come back up. Is 4 less than or equal to 12? Yes. So then I would add 2 to 4, which is now 6, and I print 6. And then 8, and then 10, and then 12. Now, when number was 12, it was still less than or equal to 12. So number becomes 14. I will print 14, even though it says number less than or equal to 12. A lot of people, when they first look at loops, they get confused and they go, okay, well, my number was 12. And so I came in here and my number became 14. So then I should leave the loop. No, you don't leave the loop in the middle like that unless I throw in a break, and I'll show you how to do that later. But it only leaves the loop when it comes up here and it checks, then it's going to leave the loop. So it was 14, it printed 14. Now it's going to check it, and 14 will not be less than or equal to 12. So it will leave the loop now. And so it all depends on how you want things to show up. So if I wanted this to be like it was to start with, we would switch that. And in this case, oops, sorry, I didn't mean to do that. Hold on. Try that again. Let's see. All right, so let's get rid of this one this time and go back to how we used to be. All right, so this is how we were to start with. So in this case, 14 doesn't get shown because I print the number before I increase it. So those are just some statements there for you to remember. And let me grab the other. Hold on. Clicking too many windows here. Sorry. Let's grab this one now and let's see what this does. This is another while. All right. So this while has a result and a counter. Now notice I have this counter here and I have the counter inside here. So sometimes you'll hear it called the loop control variable, or they'll call it LCV for loop control variable, because the counter is the one that's controlling the loop. If this is true, our loop happens. Notice I'm changing my counter in here and I'm making sure I change it so it gets closer to 10 because it started at 0. So adding 1 to it means it's going to get closer to 10. So let's run this really fast. Now, what did this do? This did 2 to the 10th power. So now watch if I did a couple of tricky things here. What if I accidentally did, let's do counter is equal to counter minus 1. Let's do that for a minute. And I don't even see something happening because my counter is doing weird stuff. So I'm like, I don't know what happened. Let's try checking the couple of things you always want to check whenever you have a loop that's giving you some problems is always check this condition. Make sure, because if I'm thinking in my head, I need this counter to go until it's greater than 10. A lot of times I'll accidentally write that. And so if you notice here, what did my counter start with? This is my step 1. My counter started at 0. So is it ever even going to get into this loop? No, it isn't, because 0 isn't greater than 10. So in your mind, when you're thinking, okay, I need to finish this loop when it's greater than 10, always kind of think about, okay, well, I want it to finish then, but when do I want it to go through the loop? So that you make sure you get the less than or the greater than in the right way. Because watch, if I would have done greater than here, it said 1 because result was 1. And then I did not go through this loop because counter was 0. It's not greater than 10. So when I printed the result, I printed my original 1. So again, this is our step 2. This is our thing that controls our loop. And then this is us changing our condition so it gets closer so that we can get out of it. Always check this. Now, if we were trying to do greater than 10, we would have to have our counter start at something bigger. Okay, so we'd have to have it start at something bigger. And then we'd have to be careful on this because counter's 20, so that would go in and result would be this. And then if I kept adding to counter, would this loop ever stop? If I have output and it's looking like this and nothing seems to be happening, it could be an infinite loop. So always go back and check, is this right? Are these right? And go and check all those step 1, 2, and 3s to make sure you're doing the right thing there. Whoops. All right, let's do another one. This one looks a little different. If you look here, our while loop always checks the condition first before it goes into the loop. Now watch this one that I'm going to show you. This one says do, and then it has curly braces. After those curly braces at the bottom, it says while, and then it has its condition and a semicolon. When you are using a do while, and that's what it is called, the thing about this loop is that you are guaranteed for it to happen one time. So if you know that you are having someone enter things or something like that, where you know, hey, I need them to do this loop at least one time, no matter what, then you want to do while. So watch what happens here. Okay, so it asks me who I am. So if I say my name, then it's going to say while it's not your name. So while I haven't entered anything, it's going to keep asking me. I entered something, right? So if I hit enter, it just prints my name. But let's see what happens when I don't enter anything. It continues to ask me, hey, who are you? Can you enter something so I can quit this loop? Sometimes you could see a do while going for a password type program because you need them to definitely enter the password at least one time to check and see if it's correct. So you'd say do enter the password. While the password isn't correct, I keep asking them to enter it. I can have other things like that. All right. So let's move back over here for a second. And let me see if I did everything. I got to do the for loop example, which I think is the next one. Let me do next page. I think I have do next page and next page. Yes. All right. Now I want to do a for loop. So I'm going to show you a for loop. Some people prefer for loops over while loops. Some people are the opposite. They all can kind of be configured so that they can all do the same thing. So watch this one. Whoops. Uh-oh, what did I do here? Oh, I missed the semicolon. All right, doesn't this program look familiar? It goes from 0 to 12, so it's doing all the even numbers. So here's where the for loop is kind of nice. The for loop has step 1, then step 2, and step 3 all in one spot. That way you make sure that you have all 3 of those if you want. So in this case, we're starting with number is 0. We will continue this loop while number is less than or equal to 12. And each time we will add number or increase number by 2. Okay. Some people accidentally do this a lot. And they would put number plus 2, and that does not change that original number. So we have to have something like number equals number plus 2, or we can use a shortcut notation that we talked about last time, which is plus equal 2. And that means the same thing. So if I run it, same output. Okay, and same thing. Now this would be a little harder to change from that while loop for it to print out the 14. I would have to start it at 2, and then I'd have to have it go to 14 here. Can I still have it work? Of course. I just have to change up things a little bit differently on how I'm printing stuff out. All right, so that's the first for loop, which has again step 1 semicolon, step 2 semicolon, step 3 semicolon. Now then, I'm gonna write something out here. Let's do okay, so I'm gonna put that there real fast. And some people, when they do for loops, they accidentally do that. Let's see if I can make it work like I want. Whoops, that's going to tell me number is not defined because I have stopped my while loop and I defined my number in there. Now I could also have something like this happen. Let number equal 2. And then I could just do number equals 2 here. Now notice, I did not get the same thing. It only printed out 16. Okay, so what happens whenever you have it and you accidentally put a semicolon at the end of your for loop is that your for loop now becomes this one statement and it has no code associated with it. So it will do the whole loop and it will finish. And once it finishes, number was 16. And so now this is just like another statement and it prints out 16. So that is a huge thing to be careful of because I can't tell you how many times people forget and put a semicolon there, or they put a semicolon at the end of their if. If you had an if, and I'll show you that again whenever I go through some, if you accidentally put a semicolon at the end of that, you will have problems. In a while loop, if you put a semicolon there, you will have a problem. In a do while, you do need one on the bottom. So I will show you that again, don't worry. Okay, let's look at this one now. All right, so now we are going to go and we are going to do the power of 2. And Oh, I forgot the console.log. Hello. Well, if I could spell, that'd be helpful. All right, so let's see what our result does. $1,024, same thing we got on our while loop. So we have our results, and notice we had to start our results at 1. That's a mathematical thing, because if we started it at 0, we would have ended up with 0, because 0 times anything is going to end up being 0. Things to look at here. Again, be careful, don't put your semicolon here. Our counter equals counter plus 1. Remember, don't just leave it like this, because that'll cause you problems. And you can actually write it like this and make it a little bit shorter and say counter plus equal 1. Or even better, since we're only increasing by 1, we can go counter plus plus. So that's another good way to write, and it makes it easy to read. Now, if I run it, I get 1,024. Okay, what do you think is going to happen if I go and I take this print and I also put it in here? I'm going to comment out this one right now and not have it, and I'm just going to run it. Now, since I put the print statement inside the for, now I have what? Every single time I go through the loop, it prints. Sometimes if you're having problems and not knowing if your loop is happening, it's always helpful to put a print inside there and make sure that you can check and see what your loop is doing. All right, I think that's the last of my for loop. Okay, let's move on here. Okay, quick notes about it. Make it look nicer again. Okay, most loops will exit when that loop control variable Boolean statement is false. We can also use break, and break will jump out of a loop. Another keyword used in looping is continue. The keyword continue will make it skip that iteration and go on to the next one. We just looked at this. Instead of using counter, we can use counter plus 1, counter plus equal 1, or like I just did a minute ago, I did counter plus plus, and those will all add 1 to counter. Now let's look at an example of the break real fast. So let me get here. All right, so here we're going to break out of a loop, and I'm going to show you it with a for loop, just because this for loop looks a little different. And again, all these examples that I'm getting are from the actual course. So as you go through the course and look through it, you'll see all these. All right, so look at this. I'm going to run it real fast. So it looks like it prints 21 and stops. So let's see what's going on. Notice I have my part 1 of my for loop, but look what I'm missing. I'm missing part 2. I'm missing a condition. So that means this loop could potentially go on forever. I have my current equals current plus 1, which we just can change that if we want to. Now, this is my if current modulus 7. What does that mean? That means if whatever current is evenly divisible by 7. Okay, because I said equal 0. Remember, modulus is remainder division. So it takes current, divides it by 7, gets that remainder. If that remainder is 0, that means it was divisible by 7, and I will print it. So 21 is definitely divisible by 7. Then instead of repeating my loop, I will break. All right. What happens if I don't break? Let's see. I don't know. Do you see that now I am in an infinite loop? Luckily for me, I can just press stop here and it doesn't kill my computer, but I can press stop and it will finish. So if I didn't break and I didn't have this condition, notice it will go on forever, and we don't want that. So that's why breaks can be handy sometimes. They will get you out of that loop. All right. All right, here's some more if statements that I just wanted to show you on how they look on their syntax. So with our if, we have our condition inside the parentheses. We do not put a semicolon here, because if you put a semicolon there, you're going to have problems. With our else, we don't have a semicolon either. And with our else, we do not need a condition next to it. The only person who's going to have a condition next to it would be an if. So we could have an if with its condition and then an else with another if and have its condition. So whenever you're having your else ifs, make sure you do some kind of indentation, make it look nice, make it easy for you to come back and review. All right, now we're going to talk really quick about switch cases. Switch case is another way that you could use basically like an if else. So there is an example in action where they go through a whole switch case, and this is what it looks like. And I have it, and I'm going to show you a couple things from that actual video, but I highly suggest you watch that video because they go through it step by step and show you different things. I will point out all the different parts of the switch when I get it over here, and we'll talk about it, how it works. Let me grab it real fast. Where am I at here? All right, let's get this switch going. All right, so I have this var. Today is, remember with var, I could also say let, and it would be fine, okay? Today is 0. So what is happening here is that I am deciding that Sunday is 0, Monday is 1, Tuesday is 2, and Wednesday is 3, and so on. 6 is going to be Saturday. So 0 is Sunday, 6 is Saturday. So in this case, I'm starting to count at 0, which I told you is a common thing with computer science stuff. So I started counting Sunday at 0, Saturday is 6. So there are 7 days for sure. Now, I print out at the end what I'm going to make my date statement be. If you notice, I have 2 cases here together, and I'll explain those in a minute. But you should notice that I say the word, first I say switch. I say what variable I want to switch on. So in this case, I'm going to switch on whatever today is value is. So these cases tell me, okay, if today's case is 0 and it's 6, okay, so those are 2 different things that it could be, then it's going to do this. If the case is 1, it's going to do this. If a case is 2, it's going to do this. Now, what I want to show you here is after every case statement, there's a break. If you don't put a break, you run into problems. Some people like to put the break on the next line like this. Some people prefer to put it at the end here like that and line it up that way. Whatever works for you is fine. You just can't forget to put a break, and I'll show you what happens if you do in a second. All right, so if I were to run this, today is 0. So it says it's the weekend, it's time to program. So notice after case 0, I don't have a statement. So at case 0, it goes here and it goes ahead and does this one. And in that video, they talk about why this happens and why you shouldn't do it some other ways, like using an or and stuff like that. So I highly recommend watching that video. It's very helpful. In this case, let's go ahead and do case 1. Okay, case 1, does it work? Whoop, hello. Forgot it wasn't input. Sorry about that. Let's make today is 1. And that's Monday. That's great. Okay, let's try 6. All right. 6 worked. Okay, now let's try something. And I don't know why I keep hitting run every time. As I go through all these, I've got break. Now I have a default down here. What does default mean? Default means, hey, it didn't match any of these guys here, so I don't know what they're putting in. So I always want to have a default down here to catch in case none of these match. So let's do it as 8. And let's see if it hits that default. And so it did. It went to there, and I could have some kind of statement saying, hey, your input is incorrect, whatever kind of catch. So this is kind of my catch. So this switch you can think of, it's like an if. If today is 0, I do this. Else, if it's 6, I do this. Else, if it's 1, I do this. And so you can line it up with an if else, or you can do these cases, which kind of make it look nice. Now, watch what happens here, though. I'm going to take this break off case 1. Okay, I took off the break. Now watch what. See, I did it again. Okay. Watch when I make it Monday now. It said Tuesday because I didn't break after I had it. So when I do a switch case, if I start to have some weird outputs like that, I need to go back and make sure, hey, did I put a break everywhere? And make sure that those are working. Okay, let me think if there's anything else on switch case. I think that's it. Notice it does have curly braces around it. Again, the switch, what variable I'm going to switch on, and then all of the cases for that variable here, and then a default that catches any of those cases you didn't cover. All right. And that was the example in action. Okay, looping statements. How about a while loop with a sentinel? All right, let's do this one. What is a sentinel value? A sentinel value is a value that when you enter it, it makes your loop stop. So, well, hello. Let me try that again. All right. So we're going to grab this. All right. So I've got a prompt for them to enter a number or a -1 to stop. Okay. I'm going to tell you right now that -1 to stop tells me, oh, that's my sentinel value. And right here, I have my while. And it says, while my input value is not -1, then I go ahead and do this loop. When it is -1, I will stop. So let's watch. Please enter a number. So I'm going to do 5. 5 squared is 25. So now if I wanted to square some other numbers, 12, 58, or 17, whatever I want to do. Well, now I'm tired of doing this. I'm bored of it. So now I'm going to enter -1. So now when I enter -1, which notice I'm entering it down here. Now, on loops where they have user input and the while loop is based on that user input, a big problem that people will forget is first I have to have a prompt to start the loop. So I've got to get them to enter something to start it. After I do the loop, I have got to have them input something again, because if I forget to get another input from them, then it will never change. Input values will stay the same. Because remember, we've got our 3 things. This is step 1. Get it a value. This right here is our step 2. Some kind of way for it to stop. And then this, in case of us just adding numbers or doing something, this is actually our step 3 that gives us a chance for it to become -1 so we can exit the loop. If we don't have this part 3 inside our loop, then it will never change and we'll be stuck in an infinite loop again. So over here, I did -1 and boom, I'm done. It stopped. So that is an example of a sentinel value. All right. For statement. All right. I don't think I need to do another one of these. I'm just going to tell you the things I had talked about. These are all the things to watch about. Make sure that you're using the right conditional right here. Notice on this counter, I said counter plus plus instead of counter equals counter plus 1 or counter plus equal 1. You can use whichever you like. Make sure you got all 3. Don't put a semicolon here. You put a semicolon here, you're going to run into problems. Off by 1 errors. That's where I switched where my printing statement was, and it went from 2 to 14 instead of 0 to 12. So be careful on that too, and you might have to change your variables when you're doing that. Okay, so the do while creates a loop that'll run until the condition is false. Since it checks, hold on, let's grab this. And since it checks, it will execute at least 1 time. It's called a post-test loop. And so no matter what, it's always going to run. There, I did that again. It's always going to run 1 time. Hold on, give me a second. Hold on, I think it's stuck up there. There we go. Okay. So we're going to grab this do while and throw him over here. All right, so here's another do while. This do while has a result that's going to be a string, and we start I at 0. Guess what this is? This is our step 1. All right, where's our condition? Oh my gosh, it's at the end down here. So this is our step 3. Step 2, sorry, step 2. Our step 3 is going to be who's changing, who's my loop control variable. That is step 3. All right, initialize it. Make sure I have a condition to get out, and make sure somewhere I'm changing this loop control variable so it will get me out of it. Now I'll run it real fast. I'll do that. All right, so I is 0. I becomes 1. Result is result plus I. So now what would I want to print out? If I could type, I would probably want to print out I, and let's see what it is. Five. That should make sense. It went from 0 to 5, but you might say, wait, it says if I had to be less than 5, but I am outside the loop here. Everybody see that? If I'm outside the loop, then that means it had to become 5 because it got out of the loop. Now, let's make I 25. Now down here, I said I needs to be less than 5, but this is a do while, not a while loop. So no matter that this will not meet that condition, it doesn't matter. I go in order. So I do this first, and it says do. I becomes I plus 1, so I will become 26. Result will become result plus 26. And now I will check my condition. I did not check it until I got to the end. So I will always do this loop one time. So when I got down here to check it, I said, oh, I can't go into that loop again because that doesn't meet the condition. So now I should print 26. So a do while always happens at least one time. All right. All right, so fix the switch statement. Let me show you this one, and we're going to do it really quickly. All right, so as we're going through, here's our practice review, fix the switch statement. So I click on it. It opened up a window. So I'm like, oh, I guess I should read what I'm supposed to do. Let's see how well you understand the syntax for switch. So this is using the linter JS hint, which we did in unit 2. So it says to go ahead and copy all this. Oops. And go ahead and throw it in here. And remember, a linter is here to check things for you. It does not run your code. You would take this code and you could put it back over here into Replit, and you could check it and see if it does in fact work correctly. But if you notice, it starts off and it says, hey, you're missing a semicolon. So I look at line 7 and I go, oh, holy cow, I am missing a semicolon. And I put it. Notice it went away. Now look, this one is telling me I expected a break before your default, and I didn't do it. And so look, I can add my break. Then it tells me, hey, you have a unnecessary semicolon. Okay. Got rid of that one. Now the warning, this is an okay warning. This is talking about what version of JavaScript I'm using, and that's okay. But right here, it tells me I'm trying to use an undefined variable. So I go, oh, I forgot to give fruit type. F-R-U-I-T-T-I. And I could start it at nothing if I wanted. Now it's telling me, hey, let is only in ES6. Okay, well, that's great because I'm using it, so it's not a problem. But if I changed it to var, notice that goes away. So if I use let, it's telling me, hey, you know, something could happen. Now you could take this code and you could copy it. you may have to add a few things to test it over here. Okay, so if we did it, let's see. Okay, so my fruit type was nothing. So it said default, sorry, we're out of fruit type. And then it went outside of my switch and said, is there anything else you'd like? So let's try one of these just real fast, and then we're going to move on. Let's try cherries. Okay, so it tells me right here in the case of cherries, cherries are $3 a pound. So that's a great way to check. And sometimes if you're working over here in Replit, you may not know what you messed up on because sometimes these error messages are not as good as one of these linters. So you may decide to try it here first and then bring it over here, whatever works for you. All right. What all have we covered today? Conditionals, loops, switch cases, breaks, continue, sentinels. Let's talk about the assessment really fast and wrap this up. All right. So I'm going to go back to unit 4 like this. And here's my whole unit 4. This is all the stuff we've just talked about. So now I'm going to go down to the assessment. All right, so I'm going to get to my assessment. I'm going to say continue my attempt. I may have to refresh it because I don't remember if I saved anything. 1 through 9. Different answers, matching, output, tell me what the output is, things like that. All right, then we hit to number 10. When we get to number 10, we're going to make a temperature converter. Always make sure you read through all this stuff. You're going to prompt the user. Okay, so you say, I don't remember how to prompt. Well, remember at the beginning of this, we did some prompts where I entered things. So you can go back and you can find out how to prompt. And then after you prompt, you're going to use if else that tests for the choice. Then you'll calculate the temperature. Here, they're asking you to use document.write. If you use document.write, it will write it down here for you, and you'll actually see it down here. You can write it that way, and you can display an alert, which displays no data entered if cancel is selected for the choice of the temp. So how to complete it. It doesn't contain HTML or CSS. So guess what? We're not going to bother with either of these two windows. It tells you to expand the JS pane to enter all the necessary code and enter your code after the comments. So that means I come down here and I don't want to work with this little tiny window. And this is our code runner. So we're going to bring it down some here and make it bigger. And I can make it bigger even if I need it bigger than that. I'm going to put my prompt here. So I will put however I need to do the prompt. Choice. Wall. Notice as soon as I do that, my prompt comes up. So that's kind of a pain to have. So sometimes you might decide, okay, well, first of all, where did my let go? Your let is here. It is just really light blue. And your var up here is there. It's just really light blue. Now, notice, did you see it was telling me I was missing a semicolon? Sometimes when I do these prompts, I will comment it out, do the coding for the prompt, and then run it. That way I don't have to deal with all that. Then I'll have another one here where I prompt for the temperature. Then in here, I will have some kind of if. It'll be like if choice equal. Now I could do equal, or I could be really careful and do equal with 3 of them. And so if they said C, then I'm going to convert from Celsius to Fahrenheit. And then else I would do the other, or however you want to set it up. I'm not going to write out the whole thing because I definitely want you to practice doing this. But again, if you don't remember exactly how to do the prompt, go back and look at the other code that we have talked about. Okay, so let's finish this up. Again, the letter var is hard to see, but it's there, I promise. And you may want to comment out that alert or any kind of prompt or anything that you're doing that will be annoying. All right, that is it from Unit 4. Next week is Unit 5, the basics of functions. Completing that unit on 5 should take approximately 2 hours. We're going to talk about how to identify types of functions, how to use functions with arguments, compare the different type of function declarations, and write code that actually calls the function. Our next live session is December 6th at 5:30 Eastern, and we will cover Unit 5. Thank you, and I hope you learned something today about all this looping and if-else stuff.
All right. Well, first, let me just say, well, thank you, Susan, for taking us through that. That was great. Thank you, as always. And thank you, everyone, for joining us. And of course, if you weren't joining us live, and you had a question, feel free to leave it in the comments. We'll get to it if we see it there. And of course, just a reminder that this is just one of our larger series of videos that you can find in a playlist down below that are covering. And are just a review of Saylor Academy's JavaScript course, which you can find the full course of linked below as well. But again, thank you everyone for joining us. Thank you to Susan Hoyt for taking us through all of this, and we will see you guys at the same time next week for Unit 5. Thanks for joining us.
All right, bye. Thank you.